Hello everyone. Now we will continue with the different parameters of fabric which affect the tactile sensation. Okay. So, these are the parameters: bending, shear, fabric roughness, fabric scratchiness, and these are the tactile sensation, fabric prickle sensation, clinginess, warm and heaviness of the fabric, and type of fabric. So, these are the different sensations and related fabric parameters. Okay. So, that we have mentioned in last class that this study talks about the density of yarn, so weave density, yarn twist and yarn count. So, and here it is only polyester filament has been used, continuous filament and woven fabric. Okay. So, these are the all the fabrics related to the polyester continuous filament woven fabric. Taffeta is a fabric where it is a twistless continuous filament is used for both warp and weft yarn, and where the weave density is changed. Here weave density is changed to change the fabric stiffness. Okay. And it is a classified by crispness, smoothness. It is a smooth, crisp, plain woven fabric. It is made of either a silk or synthetic fiber. Here we have used, actually it has been taken that it is a polyester continuous filament. Then crepe de chine, it is a continuous filament with high twisted weft yarn along with the twistless or low twisted warp yarn. So, the combination which gives the small creep structure at the surface. Okay. On the surface it gives a small creep structure. Here wave density and yarn twist, weft yarn twist are changed. Okay. So, next type of fabric is georgette. Georgette where both warp and weft yarns are high twisted. Okay. This one is it is called pongi, is made of false twist textured yarn. It gives bulk. Okay. So, continuous polyester filament which is actually false twisted, and the false twist is used both for warp and weft. So, the name pongi is used mainly for fine silk fabric, okay, but that here it is used for polyester textured fabric to give fullness and flexibility. So, here again weft density was changed. So, pongi fabric it gives the fullness, softness. Okay. Chiffon, so it consists of high twisted yarn, okay, like georgette, but the difference is that one yarn is that warp yarn is jet twisted and weft yarn is S twisted. Okay. So, the characteristics of this chiffon, it is a very commonly used fabric. It gives large crepe structure at the surface in warp direction. Okay. So, due to the twist direction it gives crepe, but its direction is different. Okay. Here again weft yarn density and weft yarn twist are changed. So, these are the different fabrics we have it has been studied, and the primary hand value was actually obtained using this equation as we have already discussed earlier. Okay. So, these are the primary hand value with the it is the contribution ratio C I it gives. Now, let us see the how the different the hand expressions are actually we are getting, we are changing with different fabric parameters. A Cauchy, what is Cauchy? We have discussed Cauchy is a type of stiffness, okay? It is a stiffness. Now, the let us see take the two extreme value. So, intermediate we are not going to discuss here, let us see the two extreme value. The Cauchy highest Cauchy is it is a taffeta. Taffeta has got highest Cauchy and lowest Cauchy value it is a Pongy. So, Cauchy increases with the wave Tian density. That means, for all the fabric, almost all the fabric, if we change the weft pix per inch or pix per centimeter, the Cauchy value, that the type of softness stiffness Cauchy is talking about, type of softness feeling Cauchy is talking about, it increases with the increase in the wave density. So, for a compact fabric we get a type of stiffness which is Cauchy. And now, let us see why the taffeta is giving higher Cauchy value. What is taffeta? It is a twistless continuous filament, okay? And Pongy it is a false twisted continuous filament. That means, if we use the false twisted yarn, the type of flexibility we will achieve, it is a type of flexibility we will achieve, it gives the Cauchy value, lowest Cauchy value. Similarly, if the filaments are straight without any finish, without any twist, that means it will, this filaments will give us a continuous a beam which will give some stiffness. So, that the stiffness which we get from a continuous filament fabric, it gives the feel of Cauchy feeling. Next, Hari. Hari is the anti-drape stiffness, that means the fabric will not be able to adapt the surface of any surface. The Hari in general for all the fabric increases with the increase in wave density. So, it is clear the if we change the wave density, the type of stiffness which we will achieve will it will be anti-drape type of stiffness, where the fabric will not be able to adapt the surface. So, higher density brings about higher Hari value. Now, again let us try to see the two extreme value, the Pongy and the taffeta. Taffeta again it is a twistless continuous filament and Pongy is false twisted continuous. So, it is like earlier one. So, Hari also is actually related with the wave density, type of yarns used. Okay. So, if we try to get, so from here our idea is, if we try to develop a fabric which will have better drape, okay, better fabric will take the shape of our body, then we should have a lower Hari value. Okay. And to get that thing, we should not use a continuous filament. So, if we wear a continuous filament fabric, it will definitely be stiffer in nature, it will give certain type of tactile sensation. Sina Yakasha, it is a flexibility with soft feeling. So, as we keep on increasing the density of peak. So, that type of flexibility will drop, will reduce, and also that soft filling will not be there. So, keeping the same yarn, if we keep on increasing the weight, that the type of soft filling and flexibility will lose, it is a Shinai Akasha. Okay. So, it decreases with the wave density. So, it is concluded that smaller density is necessary to get fabric with higher Shinai Akasha. So, if we want the flexibility with little bit soft filling, so we have to reduce the wave density first. And also here if you see the taffeta, which is made of twistless continuous filament, it's again it gives lowest Shinai Akasha, its a flexibility is low, whereas Pongi it gives higher Shinai Akasha. Fukurami, it is a fullness, it is a sense of fullness or softness of fabric, and if we see its effect on wave density is not that significant, although it changes little bit, it is not, there is no stand a norm. So, trend. So, fullness and softness, it is not that the Fukurami, it is not affected by too much by the change in wave density, at least within this range. But if we see the Pongi, which is made of false twisted yarn, which gives fullness fabric and soft filling. So, if we go for, if we want fabric a soft filling fabric, higher Fukurami, we can go for this type of yarn, okay, twistless false twisted yarn, and taffeta with a say a georgette with high twisted. So, it gives less Fukurami value, fullness, because it is a tight, and even taffeta is more than georgette, that means with a lower twist fabric, zero twisted fabric gives a little bit better fullness, better softness than the hard twisted fabric. Shari, it is a crispness. Crispness always is lost when we increase the fabric yarn density, because crispness, as we have discussed, it is related with the stick slip type of nature. So, it decreases. So, if the fabric is the wave density is increased, so the crispness of the fabric will be lost. So, if we want higher crispness, so we have to use the less wave density. The larger density is needed to get lower Shari value. So, if we want to reduce the crispness of the fabric, some the filling due to crispness, the tactile sensation, we can get some scratchiness filling, that we get with the higher Shari value, higher crispness. So, if we want to reduce, then we have to increase the density. Now, georgette gives very high crispness, that is due to the creep available, that is a small creep available due to high twisted, that gives higher crispness, but the taffeta with the twistless yarn gives less crispness, because it is a twistless one, and the Pongi also it is lower, which is made of false twisted yarn. Next is the scroopy filling, kisimi. It is a kind of silk like filling. Okay. The silk filling, this silk type of silk fabric possesses this type of nature. Okay. The effect of wave density is not that prominent here. So, wave density is does not have that much effect. Okay. The effect was different with the different kinds of fabric. So, it is not. So, for taffeta the scroopy filling reduces with the with the wave density. So, taffeta is continuous filament. So, screw filling, if we take a twistless filament, if we use the lower density, then we will get certain filling, that filling is called that is screw filling. And if we increase the, if we make a compact fabric made of the twistless filament, that screw film, that Kissimmee will be lost. So, it is reducing. This is interesting. And Georgette, you said, just see Georgette, it increases little bit, okay, due to that. So, different types of fabric, they give different nature of screw filling. Okay. So, these are the different weightage that we have discussed earlier also. So, for Cauchy, its bending rigidity is measure positive parameter, whereas this shear hysteresis is the negative parameter. Shina-Iyakasa, which is actually flexibility with soft fill, where the bending rigidity is negatively it is affecting. Shari, its bending rigidity is negatively affecting, and mean deviation of mu MMD is positively affecting. What does it mean? That means higher MMD will give higher crispness. Okay. Now, try to see the bending rigidity. So, here the count of yarn is changed. Okay. So, as the text of yarn increases, the bending rigidity of the fabrics also increases, but it is interesting that twistless continuous filament, the rate of increase is very sharp, because of the it is like it acts as a beam. Okay. So, as we increase the diameter of the filament, it increases, but in Georgette, where high twisted yarns are used, it is a crepe is present. So, that is why it is also increasing, but the rate of increase is not that, it is almost flat. So, for taffeta, if we want to increase the bending rigidity, so count we can always increase. Okay. Shina-Iyakasa, it is a flexibility with soft filling. Okay. Now, here you can see with the count, if we increase the count of yarn, that means we are increasing the yarn diameter, that means flexibility will be lost, and it is at higher rate for twistless filament and lower rate in the twisted filament, highly twisted filament. Okay. So, all these parameters we have discussed, the effect of yarn count, effect of type of filament on different types of handle related aspects. Now, we will discuss the other parameters like fabric roughness. Now, fabric roughness is a sensation which we tactile sensation which we get when the fabric is in directly contact with the fabric with the skin, and that now we will try to understand the what are the factors, and if we know the different factors, then we can control the roughness. The sensation of fabric roughness is correlated with the fabric surface roughness. So, if we know the fabric surface roughness, then we can predict the roughness of the fabric, and it is related with the fabric frictional force and mean surface roughness coefficient. Okay. So, this value we can get from the objective measurement, and then we can predict the whether the fabric will be rough or smooth, and also deviation of surface roughness coefficient. So, that MMD we can get. and also fabric roughness, surface roughness is related with the compressional characteristics. Even if the fabric is rough, suppose mean deviation of surface roughness it is high, but if the fabric is highly compressible, in that case fabric may not feel rough. So, these are all interrelated. If the fabric is frictional force is very high, so for soft fabric it may be feeling may be totally different, it may not be that rough, but a fabric with very highly stiff fabric, not compressible fabric, even a small change in frictional force or small change in surface roughness will give a very rough feeling. So, it is a compressibility is another parameter which is related with the fabric surface roughness. So, fabric roughness apparently we mean it is a surface characteristics, it is not the only the surface characteristics, it is a bulk characteristics also, it is a compression. Okay. So, compressibility and compressional energy, if the compressional energy is less, what is compressional energy? It is the energy required to compress. Okay. So, that energy if it is less or compressional in compressibility is high, then the fabric may not feel rough. Then coming to the fiber diameter. So, keeping all these parameters same, if we use the fabric fiber with higher fiber diameter, then we will feel roughness. So, it is a fabric tensile characteristics or fiber tensile characteristics that is directly related with the roughness. A fiber with a higher Young's modulus will give roughness. So, breaking elongation and breaking load. So, and tensile characteristics of fabric also, a fabric is it is a very stiff fabric will give rough sensation, breaking elongation and breaking elastic recovery of fabric. So, it has been studied and observed that the roughness sensation of woven fabric is less than the roughness sensation of knitted fabric, and the study carried out on nylon monofilament fabric of woven and knitted fabric. So, perception of roughness increases with increase in filament diameter. So, as we increase the diameter of the monofilament, the perception of roughness will increase. That means, if we produce a fabric with a microdenier filament, another fabric with a coarse monofilament, the coarse monofilament will give a rough feeling. This is due to the various parameters, it is a bending rigidity and all. So, ultimately the roughness is related with not only the surface roughness of fabric, but the many other parameters. Okay. So, fiber diameter and also the knitted fabric, the structure of fabric. It has been observed that knitted fabric gives the rough structure than the woven fabric. So, woven fabric due to its the proper structure, it gives the little bit less roughness than the knitted structure due to its loop structure. Okay. This is the roughness sensation, it is a sensation received by subjective measurement and fiber diameter. So, with the increase in fiber diameter, roughness sensation increases, and knitted fabric is rougher than the woven as far as sensation is concerned. Now, prickle sensation. Prickle sensation we have discussed a lot earlier how to measure the prickle sensation. Now, the parameters, what are the parameters which affect the prickle sensation? One study in 1988, it shows the fiber diameter, fabric thickness at low load, that means amount of hairs it measure. So, at low load that we have seen earlier, at low load and surface roughness has directly correlated with the prickliness. So, higher roughness, higher fiber diameter and higher number of hairiness, the fabric thickness measurement, it has got direct correlation with the fabric prickle sensation. Another study which says the density of coarse fiber, number of coarse fibers per unit area influence the fabric prickle sensation, that we have already discussed. So, number of coarse fiber it is projected and its density if it is high, then it gives proper prickle sensation. Okay. So, variation in diameter distribution in individual fiber, that is very important. So, if a fabric is made of 100% at proper coarser fabric, coarser fiber, that will give a certain prickle sensation, but another fabric is made of fiber of mixed diameter, like fine fiber, coarse fiber mix. If the diameter distribution, that is a coefficient of variation of the fiber diameter, if it is high, then that fabric will give us higher prickle sensation. That is the reason the wool fiber gives, a coarser wool fiber gives higher prickle sensation than coarser, say any synthetic fiber. Say if we produce a fabric made of very coarse polyester or any other synthetic fiber, coarse synthetic fiber, staple fiber, where sufficient hairs are projected, another fabric made of the wool fiber, coarse wool fiber. So, the coarse wool fiber gives the more prickle sensation due to the fact that wool being a natural fiber, it does not have the same diameter, it has got the diameter variation, it has got very coarse and finer also, medium. So, that due to this variation the prickle sensation is more, because the if the all the fibers are coarser, then it does not mean that it will give the prickle sensation more. So, for polyester, coarser fiber gives less prickle sensation than wool, mainly due to the coefficient of variation of diameter. So, for polyester diameter variation is least. Next comes the fabric scratchiness. It's again related with the frictional characteristics. So, it's related with the fabric tensile characteristics, breaking elongation, work of rupture and the modulus. Now, try to see same fabric, suppose same fiber we are using, one fabric is stretchable. We have developed a fabric, the coarse sheath type of fabric, which is say stretchable in nature, and another fabric made of the same fiber which is not stretchable, or else we can see the woven fabric, and a knitted fabric. So, woven fabric is not that stretchable, okay. Its elongation is not that high, its modulus is high than the knitted fabric. Knitted fabric is stretchable in nature, like in weft knitted fabric. So, weft knitted fabric will give lesser scratchiness because of the extensibility, or if we use a fabric with higher extensibility, it will give less scratchiness. Fabric surface roughness. So, with the increase in surface roughness, obviously it will give scratchiness. Okay. Frictional force, mean surface roughness coefficient and deviation of surface roughness coefficient, these all give the sensation of scratchiness. Okay. Compressional characteristics, that as we have discussed earlier also, that roughness, the scratchiness also, a fabric with very highly rough structure, but highly compressible may not give the scratchiness. So, that these are all related, compressibility, linearity with compression. So, all these parameter are related with the scratchiness. So, there are the fiber properties which affect the scratchiness and fabric properties which affect the scratchiness. the fiber properties are, the fabric scratchiness depends on the fiber properties, which is first is flexural rigidity of fabric. So, higher flexural rigidity will give higher scratchiness. So, we need a fabric fiber with a very soft fiber. So, to reduce the flexural rigidity, we can use the fiber diameter simple. So, that way it will give less scratchiness. So, that is why coarser fiber always give scratchy feeling than the finer fiber. Frictional characteristics of fiber. So, fiber frictional characteristic, we have to use a fiber with less frictional coefficient. So, flexural rigidity of fiber, it is dependent on the fiber modulus, cross sectional shape, linear density and density of the. So, this density is related with the its a polymer characteristics. So, this and fiber modulus is also for polymer characteristics. Okay. So, this if we change this, if we can control this flexural rigidity, we can control the fiber scratchiness. Okay. So, fiber flexural rigidity and fabric scratchiness, they are actually directly related with the straight, very actually very highly correlated with this scratchiness sensation. So, higher flexural rigidity will give higher scratchiness sensation. Higher friction gives higher scratchiness. Okay. Fiber with low friction like nylon or rayon, this nylon and rayon they give they have the low friction, it show lower scratchiness than predicted from the flexural rigidity. So, if we predict the if we use the scratchiness as a function of flexural rigidity, then nylon gives a lower value because of the its lower friction. So, friction, so it is related with the friction, flexural rigidity, diameter of the fiber. So, that if we understand this parameter, then we can control the fabric scratchiness. So, if we have a problem with tactile sensation of higher scratchiness, then we can control with all these parameters. Next comes another feeling, uncomfortable feeling, which is clinginess. The clinginess it is a nature which actually it is a fabric tries to stick to our skin, and fabric only sticks to our skin when our skin is wet. That means, a fabric which is comfortable in this cold and dry temperature may not be comfortable in hot humid temperature. So, you must understand the what is clinginess and how to eliminate by selecting the fiber characteristics. So, clinginess can be avoided by wearing fabric having high wickability. So, if the sweat, whatever sweat is it's coming out from the body, if our fabric is able to wick, to absorb and wick the all this take away the sweat and make the skin dry, then we will not have clinginess. Okay. Under condition of profuse sweating. So, when person work, it is a workwear for particular workwear. So, in hot and humid surrounding, that type of condition, if the fabric's tendency will be will to cling with the body, and then it gives the different tactile sensation which is uncomfortable in nature. So, for workwear we should be very careful about the clinginess characteristics. Okay. And that means, we have to use a cloth, we have to use a fiber which is very highly wicking, weak characteristics. Okay. And clinginess test we can do to to measure the amount of clinginess feeling of the fabric. It is the clinginess tension, is the tension required to remove a fabric from a wet surface. in a wet surface the fabric is there. Okay. So, in this table if you pour water, then a fabric is placed in that, and how much force is required to take away the fabric, it is a clinginess tension. So, this is measured with this principle. Okay. Now, this is the surface, okay, and this yellow one is the fabric one, and its water is placed. The wet fabric is placed against the porous and water soaked surface. This is the porous and water soaked surface, and it is pulled nearly parallel to the surface, and then the tension is measured. So, with the help of tensile tester. It is a very simple test, but this gives an idea about the clinginess characteristics. The maximum tension which occur at the fabric when it begins to slide, that is the clinginess tension. Okay. Is plotted against the water content of the fabric. So, you keep on changing the water content, and then we try to measure the tension. So, that gives an idea about the at different level of sweating what will be the clinginess testing. Now, here this we can take our actually our hand, our body surface as a another surface, this surface. Okay. We can so this one can easily develop this instrument, and one can test at different level of sweating what will be the clinginess tension for different types of fabric. So, this is the relations between the clinginess sensation and clinginess tension. So, there is a very good correlation between these two parameters. So, what are the various factors which affect the clinginess? Okay. So, lower flexural rigidity of fiber gives greater clinginess. That means, if we use not only fiber, it is a yarn also, or it is also fabric. So, if we use a fiber with a highly flexible fiber, or maybe one is a coarse fiber, another is fine fiber. So, coarse fiber will have lower flexural rigidity, and that will give us more clinginess. That means, it will try to actually take its the shape of the surface. Okay. And when it is clinged or it is wet, it will try to stick to the surface. Okay. So, it may be due to the, so the lower flexural rigidity means it may be due to a lesser ability of fiber to break up the water film caused by adhesion between fabric and the skin. So, this when the sweat is present in our the skin, so it will form a film, water film, and it will form a bond with the skin and the fabric. The lower flexural rigidity means it will try, it does not have the that much force to break this the bond. So, if instead if we use the higher flexural rigidity, whatever bond it is trying to form, due to its rigidity it will try to break. So, that means the fabric very soft fabric, very highly flexible fabric always give this type of problem of clinginess. So, that we can in our daily experience we have seen, if we wear very fine fabric made of cotton, very fine fabric, it gives the, it tries to stick to it is a clinging force. So, that type of sensation we may not get if we wear a coarser fabric, and this clinginess we do not get that feeling in the dry condition, dry and cold and dry condition. Okay. Only the problem comes in hot and humid condition. So, this the water film can be broken by using the fiber with higher flexural rigidity. So, the relationship we can see, the higher flexural rigidity gives the lower clinging tensor. Okay. Next comes the warmness and heaviness. So, warmness and heaviness is another tactile sensation which we receive. It is a combination. It is a very highly uncomfortable sensation. The fabric warmness and heaviness, it's a not the separate. You cannot separate the warmness and heaviness. It's a combined. This sensation is it's a very highly it gives a discomfort. Okay. The rating of tactile sensation of heaviness alone is very low. Alone heaviness is its a tactile sensation is low, like the heaviness is always associated with the warmness, and two sensations have been always combined, like a heavy fabric, like with the higher GSM, higher mass, heavier cloth we are wearing at air conditioned room, that we may not feel that much discomfort, but the same fabric will be highly discomfortable when it is warm and humid. It is at high temperature, it is warm temperature, that heaviness of the fabric, it gives different types of sensation. It is a tactile sensation. So, that means warmness is associated with the heaviness. So, heavy fabrics we can always use at cold temperature, but at warm temperature, whatever may be the condition, the fabric always we should try to develop a fabric with lighter fabric, lighter in mass, then only it will give a comfort. Otherwise, we will get a combined sensation of tactile sensation, which is a discomfortable sensation. So, warmness might be more dependent on fabric thickness. So, a thicker fabric will give more warmth than its weight. So, weight fabric may be heavier, it may not be warm. Okay. So, a thick fabric will always give the warmness. So, we have to now the sensation of warmness and heaviness we have to measure. How to measure the warmness and heaviness sensation? So, first if we want to measure the get the idea about the warmness, we should measure the thickness, and if we want to measure the heaviness of the fabric, it is more dependent on the weight of the fabric than thickness. Okay. So, we will measure the thickness weight of the fabric. So, and when we are talking about the warmness and heaviness, they are interrelated, then we have to have certain parameter which is product of fabric weight and fabric thickness. So, we can if we get a parameter which is product of fabric weight and fabric thickness, which will give an idea about the warmness and discomfort about related to warmness and heaviness. So, this product it gives a better idea the objective value about the sensation of warmness and heaviness, the discomfort due to warmness and heaviness, it is highly correlated with that this product. Okay. Now, we have discussed all these aspects of the tactile sensation and fabric handle related characteristics, roughness, scratchiness, smoothness, all these characteristics we have discussed, and basically all these characteristics are actually it can be improved by fabric finishing. So, it is said that cloth is made in the finishing. So, whatever may be the characteristics we are if we want to say make the fabric reduce the fabric friction or improve the fabric surface roughness, we can finish the fabric. If we want to make the fabric smooth or fabric flexible, we can finish. Finishing may be chemical finishing, may be mechanical finishing. So, whatever fabric we are producing, if we feel the tactile sensation, tactile finish, tactile comfort is not achieved, then we can incorporate extra finishing. If we have, if we feel that a fabric is not that much soft, we can give the softness finishing. If we feel the fabric is not that compressible, we can also improve the compressible finishing. So, fabric finally is made in the finishing for improving the tactile sensation, for improving the comfort. Okay. So, there are many types of finishes available, we are not we will not discuss here. So, we can improve say compressibility characteristics, we can improve the warmth by brushing, we can improve the softness characteristics by various various finish. So, if we understand all these parameters, if we understand the effect of fiber characteristics, effect of fabric characteristics, effect of finish characteristics on the tactile sensation, then we can develop a fabric with very highly comfortable fabric for as far as tactile comfort is concerned. So, with this we will end the session of tactile sensation. Thank you.